Hello good day viewers. In this tutorial we are going to find a solution to this nice radical equation. The question was posted by Mind Your Decision, but the only difference is that he used the left hand side, simplified the values of x to get 2, but I decided to plug in 2, solve the equation and obtain that value of x. Alright, let's get started. So let's talk about domain. Let's start with this one. We don't want it to be negative, remember. So 2x minus 1 will have to be greater or equal to 0, which means what? If you take negative 1 to the other side and divide both sides by 2, we have x greater or equal to 1 over 2. So will this satisfy the two radicals? Let's find out. You know, x greater than 1 over 2 means x can be 1 over 2 or any other value greater than 1 over 2. So let's assume the least, which is 1 over 2. Plug it here. 2 times 1 over 2 is 1, and 1 minus 1 is 0. Then if this is 1 over 2, we have 1 over 2 plus 0 is still 1 over 2. You see, it's satisfied because we don't want it negative. And you can choose other values greater than 1 over 2, like 5. 5 times 2 is 10, and 10 minus 1 is 9. Square root of 9 is 3. So if this is 5, we have 5 plus 3, which is 8. You see, it will satisfy. So what about this one? You know, for it to satisfy, because we have minus here, x has to be greater than this, otherwise it will be negative. So if x has to be greater than or equal to the square root of 2x minus 1. But we have already seen that this is greater than or equal to 0, right? So let's square both sides. We have x squared greater or equal to 2x minus 1. This is greater or equal to 0. You can bring all terms to the left hand side. X squared minus 2x plus 1 greater or equal to 0. This is a perfect squared quadratic expression. That's x minus 1 squared greater or equal to 0. You know that this is true for all real numbers. Whatever negative number you take, you square that, it will be greater or equal to 0. And hence our domain is what? X greater or equal to 1 over 2. All right, let's get started. I would like to apply substitution here. I would like to declare this with u and declare this with v. So let me start by adding u and v together. This is equal to x plus the square root of 2x minus 1, then plus x minus the square root of 2x minus 1. You can clearly see that this will cancel this. All we have is 2x. Therefore, u plus v is equal to 2x. What about the product? U times v is equal to, just observe the difference between these two is plus and minus. Therefore, if you multiply them together, it's nothing but difference of 2 squares. You take the first term x, you square that, you subtract. You take the second term, you also square that. That is 2x minus 1 under square root. You square that. This will be x squared minus the whole of 2x minus 1, because power of 2 will clear the square root. So we have x squared minus 2x plus 1. If you expand, this is a perfect squared quadratic expression that can be factorized as x minus 1. This one is nothing but half of 2. Then you square whole. This is uv. So now let us back substitute. So we have square root of u plus square root of v equal to 2. Square root of u plus square root of v equal to 2. Let us square both sides. We square this. We square this. First term squared, that will be u, plus second term squared, that will be v, plus 2 multiplied by this multiplied by this. If you multiply the two radicals, you will have square root of uv, and this is equal to 4. But what can you remember? U plus v is nothing but 2x. You can see that here. So we bring back our 2x plus 2 multiplied by the square root of uv is nothing but x minus 1 whole squared, x minus 1 whole squared, and this is equal to 4. Let us divide both sides by 2. 2x divided by 2 is x, plus 2 divided by 2 is 1. So we have only square root of x minus 1 whole squared. And this is equal to 4 divided by 2 is 2. From here, we cannot just go ahead and clear this because we don't know whether this is going to be negative or positive, right? Therefore, we have to take absolute value. Therefore, we have x plus the absolute value of x minus 1 equal to 2. This value here can be negative or positive. It's only the absolute value that can transform it to positive or power of 2. So let's assume it is positive. If it is positive, it will remain x minus 1. So we have x plus x minus 1 equal to 2. We have 2 x's here, minus 1, and you can take minus 1 to the other side. You have 2x equal to 2 plus 1. 2 plus 1 is 3. You divide both sides by 2. You have x equal to 3 divided by 2. This is one of the solutions. Now let us come back to our absolute value. Let us consider it as negative. If it is negative, we have x minus the whole of x minus 1. If it is negative, this is equal to 2. And the moment you expand this bracket, you have x minus x plus 1 equal to 2. And you can see that x minus x is 0. And if you take this one to the other side, you have 2 minus 1, 1. This is nonsense. It makes no sense, right? Therefore, it implies that x minus 1 is positive. And if it is positive, the value of x is 3 divided by 2. You can test it in the main equation to see whether it is going to satisfy or not. Just check for x equal to 3 over 2. Simplify the left hand side and see whether you're going to get 2. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.